Good afternoon, everyone, to another session of the Purple Talk invite. This is week 11, and my name is Sandeep Ragurajan. I am a technical consultant with Extreme Networks, and today we are going to be dealing with link aggregation groups. So we are going to see uh, just the how we implement link aggregation on the extreme switches, and we'll see what are the basic types of link aggregation groups that are available, uh, dynamic and static. It's a very short topic, so it will be short and sweet. So I'll just give you a brief idea about link aggregation. Probably most of you are already aware of link aggregation, and we'll just see. Just give you a brief idea of how it works, and we'll see the uh, product specific information for extreme switches, uh, and we'll see the dynamic and static. It's just the only difference is the way you configure it. And we'll see some show commands, so that this will help you in your day-to-day activities. Link lag is generally used everywhere, so you're more and more you're going to be seeing how lag is to be configured, and this is going to be helpful for your troubleshooting as well. So lag, when you say, there is just basically two types. One is dynamic and one is static. When you say link aggregation control protocol, that is the dynamic version of the lag. So uh, basically, when we say lag, we're just bundling a few ports together so that there's more redundancy, there's more bandwidth. We'll see what all types, what are the benefits of using lag. We'll just come to here. So I have this uh, picture here which shows how lag is. So we are combining two or more links together so that you have more bandwidth, and there is more redundancy, because even if one link fails, the traffic is sent through the other link. So you can use lag to connect to switches, or you can also use lag to connect between the switches to the server or to a router, etc. You're just increasing your redundancy and your bandwidth. So coming back to link LACP, which is a link aggregation control protocol, this is nothing but a dynamic version of lag, and the standard for this is 802.3 AD, and it is the same thing as in static also. Uh, I mean, you are on static, you're going to be manually configuring the links. With LACP, the thing is it is also backward compatible with static lags. So if you got any devices which do not support the newer LACP or the dynamic lag, you can use static also with those switches. So it is backward compatible. Uh, so what do you get with link aggregation is you get, as I mentioned previously, you get more data channels, you have higher bandwidth, and of course redundancy also you get. And it is a very cost effective way of increasing your bandwidth, because say you have just 1 gig links, and you want to ensure that you need to get more bandwidth. Say you have one server uh, which uh, which needs to be connected all the time, and you do not want that link to go down, and sometimes the link can get saturated, the 1 gig link. So instead of going for a 10 gig link or a 10 gig port, you can just combine some of your ports together, and maybe you can get 2 gig or 3 gig depending upon the links that you are bonding together. So it's very cost effective way uh, of increasing your bandwidth. So as I mentioned previously, it is also providing you redundancy and fault tolerance, because even if one link on the lag fails, the traffic is going to be forwarded through the other links. But there is generally a misunderstanding that uh, in lag uh, we are like distributing the traffic equally among all the links, but that's not how it works. It's generally sent through only one link. Only if that one particular link goes down, or if it gets saturated, the traffic will move to the other links in the line. We'll see how that works. We'll see. I would not be able to go much in depth about the algorithms and how it works, but I can give you a brief idea about that. So, so, uh, so when you add one or more links together, it becomes a single logical link. So when you're doing the configuration also, you should do it on the, so there is a master port when you're adding links together in lag. So there is a master port, and there are several other grouped ports. So the configuration that you only need to do on the master port, and it will get pushed on to the other other ports that are part of the same group. So it's a logical link, uh, whether it is for spanning tree or anything. So you only need to do the configuration on the master port. So you can aggregate the following links like 10 Mbps, 100 Mbps, 1 Gbps, 10 Gbps, and 40 Gbps. Only thing to remember is all the physical ports that you are grouping together should be of the same speed. And for for you all to know, link aggregation is supported on all extreme switches. So this is the diagram we had seen previously. So if you'd like to, if you have a very uh, typical server which needs, which is of very important server, and you need connectivity to the server, it's always better to have lag configured, so that even if one of the links fail, even in terms of bandwidth and in terms of redundancy. So what are the benefits of lag? One thing is, if you are using LACP, you're going to get dynamic configuration, and if the link fails, the traffic is would get moved automatically to the other ports. And uh, there is also an option, like for example in extreme switches, if you have like you have an option of configuring about 16 links together to form the lag. And but although you configure 16 links, only 8 ports of that or the 8 links will only be active or part of the lag at a time. So uh, only if one of the ports among the 8 fails, the ninth link or the ninth port would get added to the lag again. So you can do this dynamically only using LACP. So that's one good factor of using LACP. Another thing is, as I mentioned previously, you have higher link availability, because depending on how many links you have, all of the links will be active, and if any of the links fail, the traffic is automatically going to move to the other ports or the other links in the lag. Increased bandwidth. You are, as I mentioned previously, this is not exactly um, what would you say? Traffic is not distributed equally among all the links. This is not how lag works. Although you get increased bandwidth. Um so say for example you have two links, two 2 gig links, and traffic would generally And if they are part of lag, traffic would generally pass through only one of the links, and only if that link gets saturated will it move to the second link. So it is not exactly what would you say? Um, the traffic is not equally shared among all the links. That's not how lag works. But you do get increased bandwidth because if the first port gets saturated, the traffic is going to move to the second port. Uh, it is, as I mentioned previously, it is backwards compatible. That is 802.380 is nothing but LACP. So if you have a device which does not support LACP, you can actually go in for a static configuration. So these are the maximum lags that are supported for on extreme switches. So BD 10K, 12K, and 20K. It supports maximum 128 lags. And as I mentioned previously, it is a maximum ports per lag is 16, although it mentions that you can configure 16 ports. Only 8 will be active at a time. But on 8K and the Summit series switches, you have you can have 8 ports per lag, and the number of lags that can be configured for BD8K is 128 or 64 depending on what switch you are using. And on the Summit series, it is 128 lags. So when forming a lag, you have an option of configuring what type of algorithm the lag uses. So generally, uh, people are not aware of what the algorithm is. So the main types of algorithms that it is going to use is, if it is L2, it is going to be using MAC, and if it is L3 and L4, it is IPv4 with the port number L3 and L4. And you can also use IPv6. So if it is using IPv6 also, it is going to be L3 and L4 is the algorithms that it will be using. Uh, this is for depending on how the traffic is forwarded in the lag. So when you configure this, when you mention this, mention what type of algorithm it needs to use. So if you say you want to use the MAC or L2, it is actually going to the switch is actually going to compare the source and destination MAC addresses of the end systems and then calculate on and depending on that, it will use an the XOR algorithm or the CRC algorithm, and based on the output of that algorithm, it will choose which link to use. So link 1 or link 2. So these are if you have two links, link 1 and link 2, it will actually use the source and destination MAC addresses, and using that, it will perform either using an XOR algorithm or a CRC 16 algorithm, and it will calculate, and based on that output, it will decide on whether it needs to use link 1 or the link 2. So as I mentioned previously, not all links will be used at the same time in lag. Only if one link gets saturated, it's going to move to the other link. Otherwise, if there is just although you have 8 ports in a lag, if it is not required, all the ports will not be used. So the the decision is taken to by the switch. If you tell it to use the L2 algorithm or the MAC, it is going to uh, calculate or decide on which link to use using the MAC address of the which is the source and the destination MAC addresses, and it will perform an calculation and then decide on which link to use for sending the packets through the link. So these are the algorithms that the different switches support BD10K, 12K. So all of them will support L2 or L2, L3 or L2, L3 and L4. So when we say L4, it is nothing but uh, your ports, and so you can configure the algorithms using this command, which is nothing but configure sharing address based, and you mention whether it is L2, L3 or L4. And you can also mention whether it is a LACP or static. Only if you mention LACP specifically, it says that it is LACP. Otherwise, it will be considered as static. So BD20K supports L2 source MAC, L2 destination MAC, L3 source IP, L3 destination IP, IPv6 source IP, destination IP, and the command is the same. So broadcast, multicast, and unknown unicast packets are distributed across ports in the lag and are subject to a different internal hashing algorithm. So that uses a different algorithm, but the algorithm which I was mentioning previously is for known unicast packets, which is just between the two end systems, source and destination. Uh, Packets may not always be forwarded down the same lag port as the session packets. So it's not necessary, it should just take the same path. Depending on the end systems and the source systems, the links may vary. So this is the command that you would use to configure lag, to create the lag. This is just one single command that you need to use. Enable sharing, and you mention the master port followed by grouping. Grouping is nothing but you need to mention the number of ports that will be part of the lag. So you will say enable sharing followed by the master port and then grouping. In grouping, once again, you need to mention the master port as well. So if you want to set up a sharing of ports 1 to 4 and you want the master port to be 1, the command would be something like enable sharing 1 grouping 1, 2, 3, 4, and then you choose the algorithm, which algorithm you need to use, and then you mention LACP if you want dynamic LACP. So if you don't specifically mention LACP, it is going to be considered as static. Most important thing which I forgot to mention is what the configuration on the local end and on the remote end should match. So whenever you're configuring lag, you need to ensure that both sides you are using same type of configuration. So on this end, if you are using LACP uh, as for lag, on the other end also you need to use LACP. Or if you're using static, you need to mention this is static, and on the other end also it should be static. So it needs to match, otherwise the lag would not form. So if you want to see your configuration, the LACP configuration, or to verify how LACP is configured, you can use this command show LACP lag followed by the master port. And the next command is to configure LACP, which is the topmost command, which is enable sharing, is enough to enable LACP and also configure it. But if you want to add, for example, additional ports, or you want to make additional configuration changes, you can use this command for the already enabled LACP, which is configure sharing master port, and then you mention what are the type of configuration that you want to do. For example, if you want to add more ports, you can mention add, or you want to delete some ports, you can mention delete. Activity mode passive. Okay, I didn't mention about this. So when configuring LACP, the thing to remember is uh, both systems which are connecting together using LACP, the local end and the remote end, both would actually send LACP BPDUs. So they exchange packets between each other for forming the lag. And when doing this, both of them can either be active. Active in the sense, uh, active participants will actually send LACP BPDUs. So both of them will send BPDUs to each other, LACP BPDUs. But passive would not send any LACP BPDUs. Uh, so when you're configuring it, if you make both ends to be active, the LACP would come up. Or you can make one end as active and the other end as passive, but you cannot have both ends as passive. So you need to ensure that both ends are not passive, so that they send LACP BPDs to each other. So you can have one active and one passive. Command is pretty similar for static. The command would be enable sharing master port grouping and followed by the grouping list. And the thing to remember is if you don't mention any algorithm, it's going to use the L2 algorithm by default. And as previously, to change any details in the lag or any configurations, you would use configure sharing command. Show sharing is one command. We'll see the output of this command. I've taken a screenshot of that. And to disable the sharing, the command would be disable sharing master port. So this is how the output would look like on a switch. So if you do show sharing, so if you see here, we have a static LACP configuration and I'm sorry, a static lag configuration and a static and LACP configuration as well. So we have two configurations. One is for the static, we have used the master port as 5 and the algorithm is L2. And the links that are the ports that are part of the lag is 5 and 6. And if you move around, you will see AGG MBR is aggregate member, which is it should show as yes. Only then the link is active. Or if you see the output of here, only the configured link 5 is actually active in this switch. So that's why it shows the link is to be active. And if you see down with the master port 11, they have configured LACP and the algorithm they've used is L2 and the links, the ports that are part of the LACP is 11 and 12 and they are in a ready state, the links. So there is nothing connected there. So that link is not up. So this is some of the ways that you can check if LACP is up or not. So 5, the master port 5 configuration seems to be good because the static LACP, whereas 11 there seems to be nothing connected there. So which is why the ports are still showing it as in ready state. So you want to specifically look for information about one particular lag, you can mention show LACP lag and mention the master port. So that will also give you some information. So here it tells you what is the key that it use. So on a lag, all the ports would use the same type of key. Uh, so for example, on this, say you have 11 and 12. So 11 and 12 will use the same type of key. Because of this, the switch understands that it is part of the same lag. And on the command, you can see here, it mentions what is the partner MAC address, priority, and the actor MAC address. So if you come below, you will see which are the member ports, etc. And you have some more information over here and some flags as well. The information about the flags is given down, whether it is synchronized, timeout, activity, etc. So these two commands pretty informational actually for defining LACP or static configuration. Uh, with this, we've actually come to the end of the uh, session for link aggregation groups. I hope this session was useful, and this was actually a short session because there's not much in LACP. The next session would be at least a 45-minute session. And thank you all for watching, and hope you all have a nice day. Bye bye.